So today we're going over chapter 5, section 6, parallel and perpendicular lines. By the end of the lesson, guys, you should be able to identify and graph parallel and perpendicular lines. We can write equations to describe lines parallel or perpendicular to a given line. You guys should be able to do this by the end of today. So parallel lines. Our lines are parallel if they're always the same distance apart, called equidistance, and will never meet. Just a reminder, just remember, they're always the same distance apart and never touching. So if I were to find the distance anywhere between this line right here, it would all be the same, as well as if I do it here, it would all be the same. Now, a real life example that you guys see often that are parallel lines are ladders. They have two lines. Obviously, the middle ones are not parallel, but the two side ones are parallel to each other. Also, the board that we have in front of the class, these two lines are parallel to each other. For example, the top one and the bottom are parallel, as they're the same distance from the top and the bottom, and they will never touch. So we have the sides of the ladder. That's an example of parallel lines, and the top and the bottom of the board. So guys, we've been dealing with slope for the past few sections, which it's a key concept of parallel lines. So in words, we have non-vertical lines are parallel if they have the same slope and different y-intercepts. Vertical lines are parallel if they have different x-intercepts. And then, for example, we have this graph, y equals a half x plus 1 and y equals a half x minus 2. Our lines that have the same slope, a half, and different y-intercepts, the lines are parallel. So this is just saying that we have the equation y equals mx plus b. If we have the same m, which is the slope, in this case it's a half and a half, then the line is going to move one up and two to the right, one up and two to the right every time. So they're not going to touch at all when you're drawing the graphs. Now, if it has the same slope, so same slope is parallel. Now, this parallel line, again, same slope. If we have a different y-intercept, is fine. As you can see, we have the red y-intercept of 1 and the blue y-intercept of -2. That just means that the line crosses the y-axis at a different place, but it is still a parallel line because the slope is the same. So the y-intercepts being different is fine, it's good, it's great. We're not looking to figure out if it's a parallel line or not. We don't care about the y-intercept. We care about the slope. Now, if we have the same y-intercept and the same slope, it's just the same line. So for a parallel line, yes, the y-intercepts have to be different, but the slope is the same. So parallel lines are lines in the same plane that have no points in common. In other words, they do not intersect. So what we've been going over, the lines are always going to go up the same. We're going to rise the same and run the same. No matter what, we're just going to have different y-intercept. If you notice, this y-intercept starts at 50. This one starts at 100. So if it's going to go up 3 and 1 to the right for both lines all the time, they're never going to touch as they're going in the same direction. Again, if you can think of a road, you have the lines in between. These lines are going the same no matter what, so they're never going to touch. I'm just giving you different examples of parallel lines that you see on your day-to-day lives. So we have this example, which is y equals 5 over 3x minus 2, y equals x, y equals 5 over 3 plus 4, and y equals x plus 1. Now, just looking at the slope and nothing else, I can tell that this graph right here is parallel to this one because they have the same slope, 5 over 3. And I can tell this line right here is parallel to this one because they have the same slope of 1. Now, if I were to graph it, I'm going to graph the first one. So it's going to have a y-intercept of -2. Then we're going to go up 5 and then run 3. So we have this line right here. I'm going to draw a few more points just to kind of get the hang of where I'm supposed to be. So this is this line, number 1. I'll do number 2 in blue as well. So again, I'm going to go up 4 because that's where the y-intercept is. So that's my first point. Go up 5 and run 3. You do the same for the other side, just to be able to draw the best line I can possibly draw. So if you notice, this is line 1 and this is line 2. They're not touching. They're parallel lines. Again, the same slope. Now this is line 3. We're going to have y equals x, so the y-intercept is 0 because it's not given to us. You notice these lines are going to touch with the blue, but that's fine. You can't really do much about that. I'm just trying to draw as best as I can. This is line number 3. And then for line number 4, we start at 1 and go, again, the slope of positive 1 is going to touch the blue lines at some point. So drawing to the best of my abilities, it would look something like this. So notice how, again, it's not touching the line. The red lines are not touching and the blue lines aren't touching. Now, obviously, the red and the blue do cross each other. They don't have the same slope. But keep in mind how the red is parallel with the red and the blue is parallel with the blue. So looking at these lines, I'm going to go ahead and write the slope. The slope of this one is 2. The slope of this one is negative 2 over 3. The slope for this one, I don't know yet because I have to solve for. And the slope for the last one is 3. Again, you guys know that it's in point slope. Now this third one that I have to solve for is in standard form. So in order to move standard form, I'm going to actually just go ahead and rewrite it first. So I'm going to move the 2x over, which is going to leave me with 3y equals negative 2x plus 8. Afterwards, I will divide by 3 both sides. And it's going to leave me with y is equal to negative 2 over 3 x plus 8 over 3. Now, like I said again, I don't really care about the y-intercept when it comes to find the lines are parallel or not, as long as they're different. So we have this slope of negative 2 over 3. Now just looking at that, I can tell that negative 2 over 3 and negative 2 over 3 are the same. So these two lines are parallel. And then I can look at the other two slopes, which is 2 and 3. They're not the same, so those lines are not parallel to each other. So the only two lines that are parallel are the ones that I circled in red. Now, since the y-intercept is different, this y-intercept is 8 over 3, and this y-intercept is 3, I'm able to tell that they are parallel because they don't have the same starting point. All right, so to identify which lines are parallel, we're going to write the slopes. Yeah, we're going to write the slopes down. This one, I can't write it just yet. The slope for this one is 3. And the slope for this one is also 3. Again, the slope for point slope is just that one. Now, for the one I have to solve because it's in standard form, I'm going to go ahead and add the 3x first, which is going to give me 4y is equal to 3x plus 32. I'm going to divide by 4 on both sides, and that will give me y is equal to 3 over 4 x plus 32 over 4. Now, 32 over 4 simplifies to 8, so I'm going to actually go ahead and write that down. Now, based on the slopes, we have that these two are parallel and these two are parallel. Now, we have to look at the y-intercept. in order for us to be able to figure it out. So for the yellow one, we have a y-intercept of 8 and a y-intercept of 8. Now, since they have the same y-intercept and they have the exact same slope, well, I don't know why I wrote 8 down here. I meant to write 4. We have the same slope and we have the same y-intercept. This is the same line. So it's not parallel because they're going to be drawn one on top of the other. So this is not parallel. And then for this other one, we have a y-intercept right here of 0. And our y-intercept right here, I will have to solve it. So we're going to distribute the 3x plus 6. When I add the 1, I end up with a y-intercept of 7. So because there are different y-intercepts, these two lines are parallel. They have the same slope and different y-intercepts, so those two lines are parallel. So now we're going to go over perpendicular lines. Perpendicular lines are lines that intersect to form a right angle. So a right angle, guys, is always denoted with a little square inside of those lines. That is the only way, well, not the only way, but that's the most common way that you're going to get a 90-degree angle written out in paper. You might sometimes be written it down as 90, but perpendicular means 90 degrees. So you're either going to get a 90-degree angle like this, or you're going to get a square. Most of the times I use a square. Most books use a square. Most classes next year, everything, they're going to be using a square. So please remember that is a perpendicular line. That means 90 degrees. So a perpendicular line in words is two non-vertical lines are perpendicular if and only if the product of their slopes is -1. I'm going to go over it. And then vertical lines are perpendicular to horizontal lines. Now, this is something that you know already. It's just a reminder. If you think about it, the roof of your house or the roof of this room and the wall of this room make a 90-degree angle. Same with the floor. So you're always you see 90 degrees angles all the time in your life. Now, for the graphing, the left example, what it means by the slope is -1 is that we're going to have, if the original slope, as we have in red, is -2/3, the perpendicular one is going to be +3/2. So guys, that's the negative reciprocal. You guys remember, reciprocal, we flip it over. So that's why the 3 is on the top and the 2 is on the bottom for the second one. And if it's a negative slope, it's going to become positive. Now, if it were the other way, we have a positive slope, it's going to become negative, and it always flips. I do want to point out, whole numbers, guys, whole numbers of a slope, they will become 1/7, for example, -1/7 for this to be a perpendicular line. Remember, whole numbers have a denominator of 1. If you had a fraction 1/8, for example, or -1/8, you want to find the perpendicular slope. It's going to become a +8/1, or just 8. Again, it's a negative reciprocal. All right, so for this example, they want us to identify which lines are perpendicular. Again, we are looking for the slope. Now, when we have a y equals a number, remember that is a horizontal line. And when we have x is equal to a number, that's a vertical line. And in the last slide, we learned that vertical and horizontal lines are always perpendicular. So these two, just by doing that, we know are going to be perpendicular. Now, for this one, we have a slope of 3, and this one has a slope of -1/3. So these two are actually the negative reciprocals, which is exactly what we're looking for a perpendicular line. So this one and this one are going to be perpendicular. Again, in this case, even if you have the same y-intercept and you have the negative reciprocal slope, it will be perpendicular no matter what. So let's grab the first line, y equals to 3. So when y equals to 3, it's just going to be a horizontal line like this. And then when x is equal to -2, it's just going to be a vertical line like this. Now, for the other one, I'll graph it in blue. We're going to have y equals 3x. So we're going to start at 0, go up 3 and over 1, up 3 and over 1, up 3 and over 1. Again, I'm just drawing it to the best of my abilities. That is this line right here. And then for the last one, I'm going to plot the point 0, 4, because that's the point that is shown in this point slope. Sorry, it's 4, 0. And we have a slope of negative 1/3. So I'm going to go 1 down, 3 to the right, 1 down, 3 to the right, or up 1, 3 to the left, up 1, 3 to the left. Again, I'm just drawing it to the best of my abilities. And we have a perpendicular line. Now, since we know they're the negative reciprocal, I can add a square there to make it a right angle, 90 degree. Perpendicular line just means the angle is 90 degree. For both of these, I can do that actually. So they want us to write an equation in slope-intercept form for the lines that passes through the points 4, 10, and is parallel to the lines described by y equals 3x plus 4. So the first thing we do is find the slope of that second line because we want it to be parallel. So keyword parallel right there. Since we want it to be parallel, our new slope that we're going to use is 3. And we're going to use point slope form in order to plug in the points. Alright, so using that formula, we're going to do y minus 10. We find that from the point up there. Since we want it to be parallel, we're just going to write 3 for the slope because it's the same slope. X minus 4. So again, for a parallel line, we keep the same slope and we plug that in. Now, that is an equation to the line that is parallel to the line y equals 3x plus 4 that passes through the point 4, 10. Now, unless it asks you to put it in slope-intercept form, which is the case right here, which we'll solve for it in a second, you guys can leave it as point slope. That is fine. Now, to solve for slope-intercept form, I'm going to go ahead and distribute that 3. So I'm going to get y minus 10 equals 3x minus 12. Then I'm going to go ahead and add the 10 to both sides, which is going to leave me with y is equal to 3x minus 2. That is in slope-intercept form, and that will be my final answer for this problem. So they want us to write an equation in slope-intercept form, so y equals mx plus b, to form the line described. So it wants to contain, for number 1, a point 8, negative 12 that is parallel to that line. So since it's parallel, we want to use the same slope. So we're going to use y plus 12 equals negative 3 over 4 x minus 8. If it weren't because they wanted a slope-intercept form, we would be done. So I'm going to go ahead and distribute, which is going to give me negative 3 over 4x. It's going to give me positive
24 over 32.
6. I will subtract negative 12 on both sides, which will leave me with y is equal to negative 3 over 4x minus 6. And that will be your answer for the first one. Now the second one, they want you to contain the points 4, negative 3. That is perpendicular. So perpendicular means it's going to be the negative reciprocal. So our slope is now going to be negative 1 over 4. So if we're going to fill in y plus 3 equals the negative reciprocal, negative 1 over 4, x minus 4. Then I'm going to go ahead and distribute to give me y plus 3 equals negative 1 over 4x plus 1. I'm going to go ahead and subtract the 3 on both sides, which will leave me with y is equal to negative 1 over 4x minus 2. Alright guys, now you do have homework tonight, but this is it for today's notes.